What's up? I'm Brianna Ivy, and this is the Hear From a Student podcast. This is a public podcast announcement. This episode was filmed in a very public space on Georgia Tech's campus, which means you get to enjoy the ambiance of frantic college students running about during final season in the background of this episode. But have no fear. No matter what you hear in the background, everyone survived final season at Tech, and we survived this interview, but not without a little bit of noise in the background. So, now that you're aware, let's jump into the episode. I hope you enjoy it. Hello, Johnathan.
Hi.
How are you today?
I'm good. How are you?
I'm good. Thank you so much for taking time out of your busy schedule to join me today.
Mm-hmm.
And I'm going to start you off real simple, real easy.
Okay.
You can just tell us your name, your major, and what year you are.
Okay, cool. My name is Johnathan Radcliff. I'm a fourth year computer engineering major now.
Mm-hmm. Yeah. Final year. Congratulations on making it this far.
Thank you.
So when you came into Tech as a freshman, your major was not computer engineering.
Mm-hmm.
It was electrical engineering.
Yeah, it was electrical.
Okay, so we'll get to the switch, but why did you choose electrical engineering?
I liked working with electronics in high school. We had this kind of an exposure program in my high school to get us involved in that kind of stuff. And then on top of that, my friends and all were interested in that kind of working with Arduinos or making very simple circuits, making an LED blank or something like that. That was cool for us. And so I was trying to figure out what major kind of did that the most. And then I found out that electrical engineering was kind of that sort of vibe, because I really liked working with hardware, and at the time I didn't like coding, or I guess I didn't know that I liked coding. I kind of had a misconception about what computer science was, and so I didn't want to do that. So electrical engineering.
So what about your experience throughout the electrical engineering coursework did you think, or did you not like, or that made you want to switch to computer engineering? Was it a class, or was it your interest in really line up?
I think it was more the fact that I realized that I did like programming a lot more than I thought I did.
Okay.
Because we had an intro to CS class. It was a brand new class at my high school, and it wasn't the best experience. So I thought this must not be for me. I don't really like this. But what happened? I guess when I got here, we took the intro to programming class, because you will probably have to take an intro to programming class at some point. And I really liked it, and I wanted to take more classes like that. So I went out of my way to take more classes like that. And then, after that, I realized my major now, computer engineering, kind of does both. You can do both and use both those interests to get a degree. So that's why I did what I did. Yeah. And
you kind of touched on the next question I was going to ask, which is the difference between electrical engineering and computer engineering. Because when I first came in, some schools have them separate, but Georgia Tech puts them together.
Yeah, they do.
So what to you is the biggest difference between electrical and computer?
I think electrical engineering has the caveat of having to know a lot more about physics and physical hardware, whereas computer engineering, you can choose not to do that. Because electrical and computer engineering, especially in tech, you're right, they're very close. In all actuality, as a computer engineering major, I could take only electrical engineering classes and graduate with a computer engineering degree. But with electrical engineering, you got to know more about how the physical effects of what happens when you put electricity through a wire, or if say you want to work on a power grid, right? You want to make work on power lines or something like that. That's cool to you. You got to know how to do that, right? And versus computer engineering, you can kind of just you could do that, or you could take an extra programming class. You could how a computer reads code and do that kind of stuff. You have more freedom on the software side. I think that's probably the biggest requirement. And you can also, like, because the departments are the same, you can do that as an electrical engineering major, but you have to do those other ones. Right. That's the only thing. Yeah.
That is true. I think I realized that I like coding a little bit with some of the like embedded systems classes and things that you can take as an electrical engineer, but all of my compy friends were like hardcore coding. And I was like, that's a lot. I kind of want to do the wires and stuff too.
Yeah.
I guess you have a very unique perspective having spent some of your time as an electrical engineer and some of your time as a computer engineer.
Right.
But I guess on the electrical side, did you have any misconceptions about what electrical engineering was that got cleared up as you started doing coursework?
Yeah. I think for electrical engineering, I didn't realize like how like I guess deep it went into. Like it's a very physics based like curriculum. I thought that even things like with like circuits, you're putting together a circuit to make like a LED light up. It is actually very complex. How to do that. It's not that simple because for the most part, I was kind of using like make electronics, DIY electronics, to kind of do that stuff. And it was all very simple. So I was like, okay, cool. They're just going to teach me how to do more of this, right? And it's like, no, like electrical engineering is a huge field. You can be an electrical engineer and literally not touch a circuit. You could be a signal processing engineer and you will not touch a circuit. You know what I mean? Or you can make that career for yourself. And I didn't know how big it was. I thought it was just this one thing. And I kind of got overwhelmed with the electives that you could take. And it was a good overwhelm though. I was like, wow, I can do a lot of stuff with this. That's probably one of the biggest mistakes. I was too narrow-minded in what I thought electrical engineering was.
I feel the same way. I didn't know how big it went, but I also didn't know how like granular it was. Like I thought I was gonna just be learning about like PCB level stuff. Like you put the resistor on there, you put the IC chip on there, but we have classes where you have to learn how to make what's inside the IC chip.
Yes.
Like analog design. I was like, whoa. This is a lot deeper than I thought it was going to go. So. Now, what about, I know you did computer engineering like later, but did you have any misconceptions about that got cleared up?
I think that for the longest time, my friends were, honestly, like, as it stood when we first, like, came in, it was not, computer engineering was not the department that it kind of is now. They were a mix between the EE and CS, right? But the problem with computer engineering is you could take computer science classes, CS, computer science, you can take computer science classes, but you don't have that like priority registration. Right? And so for the longest time, like when I was in our like Georgia Tech introductory class, it's called GT 1000. My team leader, like the guy who was like mentoring me, was like, "Don't be a computer engineering because they're just like you're either going to switch to computer science or you're just not going to have a fun time being in the major." And so I was like, "Okay, cool." That staved me away from that major for 3 years. And when I actually transferred in, and then I was like, "Oh no, like." I can still do a lot of what I wanted to do in electrical engineering. Like I took EMAG. I didn't necessarily want to take EMAG, but I took EMAG. But I could also take. It also kind of showed like, you pay attention to the electrical engineering curriculum, right? And so I was very familiar with that. But then the computer engineering had things that I was interested in. I didn't know that they were offering. Like GPU programming classes. There's for like video game development, or you can do like computer networking. Because I realized I wanted to get into cybersecurity. That's like a whole field that you can just get into. So it's cool.
So many things.
Yeah, it kind of just again showed me like wow, like you don't have to give up what you like about electrical engineering to be a computer engineer, which is kind of what I was told towards the beginning of the time. So yeah, that's what I'd say.
I think that's a good point to make, because for me coming in, I didn't know the first thing about electrical or computer, but I felt like computer engineering I didn't know the most about.
Right.
If that makes sense.
That's fair too. Yeah.
Do you have a favorite thing about electrical or computer engineering? Like, I don't know, maybe your favorite thing that you learned, or your favorite thing about studying either one of them, or both?
Yeah. Wow. I think my favorite thing that I learned so far was kind of related to like digital design, I guess.
Okay.
And how that kind of like came about, because I also like embedded design and programming, things of that nature. And the first digital design class that we took, that was when I knew that I was in the right major.
2031?
2020.
2020, okay.
Yeah, that was when I knew. I was like, okay, this is my major. 2031, the lab class, no.
Okay.
Didn't like that.
Okay.
That class was not fun. But, yeah, after that, I took, like 4180, which is the,
embedded systems.
Right, and it's also something where, like, I was going to take that class anyway. Like, I already planned for myself to take it as an electrical engineering major. Yeah. And so as a computer engineering major, it also just fits, like, right into the curriculum. Yeah. And that's something that, like, I realized that I really like, because digital design is basically the design of, how do I describe this in a low-level way? It's basically how you can configure a circuit, like a little mini computer, to do very like basic tasks, and you can build on the basic building blocks like Legos to make very complex things, like in Legos.
Yes,
so,
that sounds pretty good.
Yeah, so that's essentially how it goes. Like, you learn how to make one Lego, and then from there you can make anything.
The whole house.
Right, exactly. So that's what I think that's what I like most about my time here. I'm trying to think, like, if there's any other time where I was just really blown away by a class like that. And I don't think it's really happened since freshman year.
I feel like freshman year we get introduced to a lot of things that we just have like never seen before.
Yeah.
And it's just like, wow. And then everything else kind of, like you said, just builds on top of the freshman year kind of courses. So,
right.
Yeah.
Right. Yeah. So, yeah, I guess there's no like real like surprise wow factor.
Yeah. What is your least favorite thing about either of the majors? You have so much more freedom than everybody else, because everybody else just like kind of had one and stuck with it, or switched earlier.
Yeah.
So you can just pick on answering the questions from an electrical standpoint or a computer standpoint.
I see the value in what I learned in EMAG. But as a class, like, that was just too much. Like, it was so much work.
It was. And
then on top of that, like, the content was so hard. Basically, what I realized after taking, because thankfully I didn't take 30, 40, 30, 43. That would have.
Oh, how lucky are you?
That would have set me back, yeah. Then I would have had to stay at EE.
Yeah.
But, yeah, I'm so sorry that you had to do that. I'm so sorry that you had to do that.
Yeah.
But what was I going to say? Yeah, EMAG was one of those classes, and then it was this class on like intro to computer architecture. 3057? Yeah, they renamed it 3058.
Okay.
Because they changed it from a 3-credit hour to 4-credit hour class.
Okay, makes sense.
But yeah, right. Thank you. But it's a good class. Like again, it's one of those classes where like, it's very educational. Like, you will learn a lot, but it is so much to learn in a semester that you're just like, whoa. And then our professor, the first exam, he made the test like way too hard. Like, it was kind of one of those things where he had an idea of what he thought the class was, and then the class average was not what he wanted it to be.
Like, sir, you did not teach the things that you thought you taught.
Yes, so we had to go from there. But yeah, I would say though the first one was definitely EMAG.
EMAG, least favorite?
Yeah.
For those of you who don't know, electromagnetics, the class that you just talk about, you learn about electromagnetic fields and then how they affect real life applications. So like, my professor did research with antennas and like stuff like that. So we had the whole like coaxial cable.
You were getting it.
So Yeah, that's probably one of my least. It was okay, but also, like, you see the value in it later. But in the actual class, it's just like, man, am I gonna make it out here alive?
Right, because it's one of those things. It's like, you know, how do you make sure that your USB cable isn't like losing data? Along the cable, like
attenuation, all those kind of things.
I mean, flashbacks,
great things. But okay, what is the most challenging part about studying either electrical or computer?
I would say the what's it called? The math-based nature of everything. Everything requires math. Like, there is it's a common thing sometimes in tech class, like when you take your last like math class. Yeah. And I'm gonna tell you right now that everything in computer or electrical, it's more so in electrical than computer, to be fair, but everything is rooted in math.
Mathematically based.
Because you find out that everything is math. Yeah. Like, and this is not just for this major, it's for really all of them. Yeah. But everything is math. Like, you got to learn how, like, math,
there's a mathematical equation to model almost everything.
Every single thing from how, you know, like when, I can't even describe it. It's like when you should expect from the time you push a button that the light turns on to even when you're pouring a glass of water and the little sloshing that the water does when it's like trying to level out, that has a math equation to it. Like, you can't escape it. And I think that's something where, like, coming into tech, and a lot of people, like, just to not, like, scare people away, like, we all came from a position where math is hard. Yeah. We struggle with math, right? But what you end up realizing, or what ends up happening, is, like, you do it so much that it just, like, over the course of, like, literal, like, years, you just get used to seeing it, and you kind of have an innate understanding of, like, what, maybe not, like, you don't look at a math equation and, like, understand everything, but you know, like, okay, I've seen this before. I know how to deal with an equation that looks like this, or I could study to deal with it. But the hardest thing, math.
That is. I remember freshman year taking a class, and that wasn't freshman year, whatever year we take 2040. I remember my 2040 professor like looked at the board, and like there was this equation that modeled the circuit, and he like looked at it and instantly like knew the outcome. And I remember it was after class, and I was asking him for help, and I was like, "How do you just like know this?" And he was like, "Over time, you just get an intuition for stuff." And I was like, "That's never gonna happen." But now I can look at a circuit or look at an equation and be like, I might not know exactly what the answer is, but I know what it should be, just based on like having experience of working out this math so many times. Like, it's interesting how that happens. I remember thinking that's never going to happen. Right. But now, here we are at the end of our time here. So if you could pick one skill from a different major to go along with your electrical and your computer skills, what would it be?
See, this is a good one. Yes. So my first instinct was to be like, what's it called? Like CAD, like 3D modeling.
That's mine. That's my pick. Yeah.
That's definitely like a top tier skill. If you can do what we do and do CAD, you're kind of unstoppable. Like there's really not that much that's really in your way. Yeah. The only other thing that I would potentially take as a skill is more so the I don't know if this like for computer science or like people or like civil engineering, kind of like social engineering, but just like having a better understanding for like how people interact with like, you know, maybe products or systems or things of that nature. That's like a soft skill, which is very soft skills are important.
Skills are underrated, very important.
But that's like a 2. I'll say that's a 2 because my immediate gut reaction went to CAD.
Yeah, I think that's a good skill to have. And I remember talking to, maybe it was a recruiter, I can't remember, but like sometimes as engineers we work on like things that aren't client facing. So like we'll work on the chips that go on the board, or we'll work on like something that the client doesn't directly interact with. Right. So we don't normally think about how would they use this, or how would they interact with this product, or is it user friendly? Like, does it make sense to them? Because we're working on a project now where like the nomenclature and like how we name things and what's the word I'm looking for? Label things. Yeah. It makes sense to us because we're engineers, but the people that we're providing the product for are doctors and clinicians. So we say one thing and they're like, no, this doesn't make sense. This needs to be named like, I don't know, baby temperature or something like that. And we're like, control loop temperature. And they're like, no, we don't know what that is. So I think that's a really good skill to have. Right. Especially when you want to be in like certain fields inside of engineering.
Yeah, for sure.
I think I may have touched on this a little bit, but do you have a favorite skill that you've gained?
Oh, let me think. I think in terms of wow, that's actually really, I will say that something that I kind of realized that I can do over time is you get really good at like finding mistakes, like debugging. Mm-hmm. That's something that you kind of have to learn in order to be successful. But I just had an interview where that was like part of the interview process was debugging. Like, assuming that this system is broken, can you explain what might be happening? And then they explained what was actually happening. Yeah. And then how would you solve it, right? Yeah. Because that's going to happen. Like, things are not going to work the first time around. This is like programming. You could build a circuit. I remember the first time I built a circuit in our intro to like building, systems in like 2020. Yeah. I didn't hook up power to anything. Like, I had the whole thing made.
With the MyDAC?
Yeah.
No, I did the same exact thing.
I didn't, and I was wondering, like, why is it not lighting up? Yeah. And then the teacher looked over, and he was like, "You don't have power. Yeah. What did you? What did you think was gonna happen?" Right, exactly. And so, going from there, it was, because I learned how to like program. Like, I'm pretty decent at it. I would say, even like for me, I don't like to count, but I know that that's something that I'm good at.
You toot your own horn.
Yeah, right. And I think the other thing would be like cybersecurity. Because one thing that I took when I switched, the first class that I took was this cybersecurity like hardware class, and that was one of the most interesting. Now I can't practically apply it. It was like all theory. Yeah, I can't practically apply any of it, but that was like some of the coolest like concepts that I learned. It was kind of like exposing in that same breath like how people would fail to use their systems correctly and what you should do to like counteract that. Because you find out that users don't use things correctly ever, and so kind of like in that label, like the whole like labeling concept, right? Like as an engineer, you would think it's obvious to use it like this, and somebody's going to look at your thing, never seeing it before, and use it completely incorrectly. So how do you like work around it? Yeah. Right. That was cool.
That's interesting. You mentioned cybersecurity, which is like, I guess a thread or a bucket of like the overall electrical engineer or computer engineer. Yeah. So there are a lot of different, I know there are a lot of different buckets for like electrical. I'm assuming that there are a lot for computer. What are the different like subsections of computer engineering, and do you have a favorite along with cybersecurity?
Oh yeah, I think my favorite as it currently stands is called embedded systems development. So basically it's all those like little like gadgets that are like, you might have like a home camera, like, or you like your thermostat or anything like that goes up all the way to like the camera in your iPad or laptop. That's like an embedded system because it's embedded in another thing. Yeah. And that's been really cool because it kind of mixes both very well for me. It's kind of the reason why I wanted to get into computer engineering, like just to say that was the major, because when I applied to jobs, I wanted to be like, I have both experience, But cybersecurity kind of leads into that because in some ways, like I could have specialized in like hardware security or software security, but I wanted to have an arm in. That's why I want to be able to say that I have experience in it.
That's a good one.
Yeah.
What are some of the other like?
So control systems, which is essentially how you control like. Oh gosh. how do I say this? So in a factory, right,
Mm-hmm.
there are like robots that like make cars, make whatever, like electronics, etc. Those need to be controlled.
Yeah.
And control systems is the field of telling a robot what to do. Robotics is another one, which is essentially like building and controlling like a robot, but it's not like something where it's an arm in a factory. It's more so like, no, like this is a standalone
Okay.
type deal. There's computer networking.
Mm-hmm.
So you're like the theory behind like Wi-Fi or Ethernet or any of those kinds of things.
Mm-hmm.
To some extent, there's a little bit of kind of the RF, like the radio frequency.
I feel like the buckets are so similar.
Yeah. Yes. I'm trying to think of ones that are like not explicitly
in electrical,
right? Like just to give a little bit of differentiation. But like things like signal processing, which is essentially the concept of like how on radars and like movies or televisions, like it'll see like a red dot on a radar screen that's like spinning around, or when you're approaching a grocery store with automatic doors and the doors just know that you're there, right? That sensor senses you and it sends a signal back to the computer, and that signal needs to be processed and understood, and that's signal processing.
You give me some great examples.
Right.
These are fantastic.
I'm trying to think because it's a really cool major.
Yeah.
I really like what we do.
Yeah.
And so I want.
And there's so many different things that you can do inside of either of the majors.
It's so diverse. I feel like our major truly is like one of the most diverse, like in terms of like you have like a stamp on your like on your diploma, but you can do so much with it. And more so, I think than most other majors, say like computer science, is because that's like really just like it's kind of like invent your own.
Do whatever you want.
You do whatever you want, right? But in terms of like engineering, like specifically engineering, you can't really get more diverse than.
I'm gonna toot the horn of my major. Electrical engineers, we be doing all kinds of stuff. So, when you're working on like a group project with different majors, not just STEM, but like business majors, whatever the case may be,
right.
What do you think is unique about your perspective and what you bring to the table with your major that nobody else does?
Right. So we kind of like, as electrical computer engineers, we kind of like set the tone for like what the project actually can be, because in a large sense of the like field, I guess, like when you're doing product development, the electronics set like the pace for what you can actually serve, because the business, majors will try to pitch, everything, right? And then, you'll have grand ideas for the mechanical engineers. They'll start like writing up, like models and all that stuff. But in the very real sense, like what the thing actually does is electrical. That's kind of where we are as a society, right? So like we set the bar for that. Unless you're in a team that is very like specifically like this is a chemical innovation, or this is a design innovation, right? You're going to be in a position where you're creating the thing, right? So that's kind of what we do. So when we talk to people, we tell them like, hey, this is what can actually happen.
Right.
Where can we meet in the middle?
Exactly.
I
just kind of realized that's what we do in a sense, because you have projects and the first draft will be like all these amazing things that you want to do, but then you realize you're only given a 9-volt battery. So what can you do with this 9-volt battery? Because you can't do everything. So you got to pick what it is you want to do. So I think that is a good thing that we do bring to the table, and understanding how that impacts the rest of the project.
Yeah.
What has been your favorite project to work on in these last almost 4 years?
Favorite project?
School or internship?
When I was my freshman year, actually, this is kind of, like when you're in this like major, you kind of have to do like a lot of projects. So, but when I was a freshman, I went to Stanford to do a hackathon.
Really?
Yeah,
okay.
I did.
Learning, I am.
Ooh, Tree Hacks, that's what it's called. I'm actually gonna run it back, I think, in the spring. But there's this company there called BlockFacts, and they were working on, creating a blockchain internet, and they wanted all of your user data to be owned by you, and you can choose what you publish to the public blockchain of information, things like that. It was really cool stuff, right? And I was like, well, I guess one thing that could kind of benefit from this is the transfer of medical records, because I just listened to my aunt, who was a doctor, complain about how difficult it was for her to transfer one of her patients to an out-of-network specialist, right? And that was a month before that, so I kind of looked into that, and then had this whole concept. Didn't have anything at the thing. I just pitched the idea, and I didn't win anything, but the creator of the platform was there. He was one of the judges, and he saw what I was thinking about, and me and this other girl from Stanford, and he was like, "This is great. You should totally go through develop this, right? And let us know if you need anything. Here's I got invited to the Slack. They had a whole company Slack thing, and I was messaging them, and then they also a Discord, which is funny because they play video games together sometimes. It's tough. But that was really cool, because that was kind of my first introduction to I don't know, that kind of environment. You know what I mean? And I need to pick that idea back up.
I know what I'm saying. Did you not? You didn't continue with it?
After I'll tell you what happened after so that was in the spring of 2019, right? Okay. Summer, I was working on it a little bit, and then in the fall, I was going to start talking, interviewing with hospitals and stuff on how to use that, right? And I was doing the interviews very well, kind of doing product research. Mm-hmm. That's what that's called, when you interview the users of the product to see what you actually need. Mm-hmm. And I got all that together, and then the pandemic happened. And then hospitals are still really inaccessible, and also really busy, they're flooded, right? So it's hard for you to get this kind of and it's sad because it's at a time where that would be very necessary. Yeah. And so it's kind of been slow going, but the one thing that's been good is now that the vaccines are out, it's a lot easier for me to convince, maybe not a doctor, but someone a medical specialist at the hospital to come meet with me virtually. Yeah. Now we're talking about this. So I need to pick it back up though, because I can't lie, graduation takes precedence over basically everything.
Everything else in life.
So all these side projects that you might want to do, but
yeah, that's a really good one.
Yeah, that was really fun. I think that was the first time that I really got not only was good feedback, but it was somebody really just saying this is good. Yeah. And it's from the people who made it. Yeah. You know what I mean? So they made the technology, and they're this is a good idea. You should definitely keep looking into this. And I don't know, if you ever get a chance, pitch your ideas to people. Do not hold them. The inclination is there. You want to keep your ideas close, but you need to pitch them, because people are going to use them, right? You're going to have to tell people to use your product at some point. Yeah. So
that's really good. First of all, that's a great advice.
Yeah.
Second of all, that's a really cool project. And I love when things are applicable, because a lot of what we learn for the first half of our Georgia Tech career is very theoretical. Right. And then you actually get in a place where it's okay, I can apply this theory and actually do this thing, and it's meaningful in the world. Right. That's one of my favorite things about being an engineer.
Yes. The real impact is so cool. It's so cool.
It's the best thing.
But I don't know. I mean, you have one of the best examples for real impact that I think I've ever heard of. But that's kind of the reason why I wanted to do this specifically, because I went into high school thinking I wanted to be aerospace engineer. Mm-hmm. I really liked the concept of planes, and I wanted to build things like that. I've been obsessed with planes my whole life. But then I realized that the actual part that I liked about the plane was like, maybe like designing like how the engine worked or things like that. And you can be mechanical engineering or aerospace engineering. You can do that, right? But I was more interested in like the actual like motor that turned the engine, not like how the fan blades in the engine were built.
Isn't it so crazy how everything is just layered?
Yes.
Like almost everything in the world is an interdisciplinary project.
Right.
So.
Which is why it's a disservice when like you have a lot of projects that are very that can be very like, specific to your major. Like working with other majors is one, really cool because you get to see what they study, and then two, like for instance, our senior design project is about like leakage detection in like pipes.
Oh yeah.
And,
I see you.
Yeah. So we were what's it called? Well, no, that was another team.
Oh, okay.
Continue. We're gonna like we had the same advisor.
Okay.
So because he does research in that, and but we were trying to like. We have like a differentiation, which is very complicated. I'm not gonna go into that, but that's one of those things where it's like, okay, well, you need a mechanical engineer. You also need someone who understands like how like fluids move. Period. You know what I mean? And so like your friends are learning cool stuff. That's what's cool. Like in college, like, your friends are always learning like cool stuff, and you can just bring that together and then put it in a thing, and then you realize like you said, everything that exists is very interdisciplinary. Like, it coming down to the seat that like we're sitting on. Like, yeah, sure, like a mechanical engineer maybe designed it, but like at some point, like a chemical engineer had to think like, okay, this material needs to last X amount of years.
Or material science engineering.
Yeah, and then you have material science engineering, which is a whole. That actually might be the most diverse. I can't even lie, because
I didn't realize how many things need a material science engineer.
Everything. Yeah. Like, oh gosh, it's to the point where like everything that's built, period, needs a material science engineer to just know, or at least have done prerequisite research.
Yeah.
So that a mechanical engineer can use it to build whatever. Yeah.
So that's really, really crazy to think about that. Everything.
Yeah.
Everybody works on everything.
It's all together.
You also mentioned hackathon. So can you just give like a brief description of what hackathon is?
So a hackathon is a hacking marathon, hacking meaning building. It's usually anywhere from 36 to 48 hours. You go to a school, go to a venue, meet a whole bunch of people, get an outline for the types of projects that the organizers want to see, and then you just build. Day, night. Like, most people don't sleep. If they sleep, it's only a few hours. And you build a project, and then you present it, and then you can win money.
That was really good. I did hackathon once at an internship. I don't be coding like that. And and I had friends who were heavy into coding, so I just kind of watched and like did the small stuff. But I was like, y'all are really going hard right now to build this thing before tomorrow. So it's cool to watch people sweat and type at the same time.
And that's the thing too. Like people will be exasperated.
Yes.
They will be like code, like just thinking and typing. Like it's insane. But the results, like the benefits. There were a lot of hackathons related to COVID when this was first coming out, and then because there's like money involved, like people are going to invest in these good ideas, and then from there, there might be ones about how do we like ensure social equity hackathons. There'll be ones like, hey, dedicated. I think actually, Caltech made a whole hackathon just based on like improving Caltech.
Really?
Like, it was a whole, like, name problems that exist at the school, because y'all go here, y'all know the problems.
Oh, that's good.
Figure out solutions to them, and we will pay you for your good ideas. And it's like the top prizes can be anywhere from, like, $1,000, $5,000, $10,000. It's like real money. It's not like you get, like, $50 pat you on the back.
I think the best thing that you said in that whole thing is people invest in good ideas. So that's why, relating to what you said earlier, you got to pitch your ideas. What is a skill that electrical engineers or computer engineers have that you think other majors should have?
That is a really good question. I'm trying to think of like just one.
Yeah, I know, right?
Like my favorite one. I think best thing about our major that other majors should definitely learn.
Yeah.
I think it is that like fundamental like I'll say that whole concept I said before about building the Legos to build more Legos. That kind of like concept, you don't need to get into the weeds of it, but understanding like, because that's where a lot of those talks about like limitations comes into, and I really think that other majors probably should, which I think they do. They take like this one class on like how to build a circuit, or also one thing, just a really side note, learning how to like use a breadboard.
Oh, underrated skill.
Underrated skill. Actually, I'm gonna amend my answer. That is something that every major should probably learn because that's more practical benefit than
that's a good one.
All this other stuff. Like even like you could teach people to learn how to solder, but I only know so many like computer engineers at least that still solder.
Yeah.
So using a breadboard though, that's like universal. Like if you need to do quick
test prototyping, that is really good. That's really good.
That's what I said.
I think something that I learned on this last group project that I had that was also interdisciplinary is P equals VI. Power equals voltage times current. We had a bunch of mechanical and computer engineers and biomedical engineers, and we needed help on the power side. But as long as you knew that one rule, then you could help us figure out everything else. So I thought that was interesting to see because to me it's just like an equation that we learned 4 years ago.
Yeah.
Okay, we use it all the time, but to them it was like something so new and so mind blowing. But it like helped us with the entire project.
Yeah.
So that was interesting to watch. Coming up on the last few questions.
Gotcha.
The first one is, if you worked for Webster's Dictionary and they came to you and they said, Johnathan, we want you to write the definition of an electrical engineer and a computer engineer, what would you say? Based on your experience, because sometimes we Google stuff before we come and we be like, this is not what I experienced during my undergrad.
Yeah. Electrical engineering, or an electrical engineer, someone who has great knowledge and experience in building and designing circuits, like electrical systems, who understands not only the circuit, like the thing that you would see on like a circuit board, but also what's going on in the individual components in the circuit board. That's electrical engineering.
Yes.
Right? Has that knowledge, right? Computer engineering is the study of how computer engineers are people who understand how computers process and understand their environment and each other. That's very basic, but it kind of goes into this is how a computer networking works. That's how how to teach a computer to read code, all that, how to computer engineering is a study of how to teach a computer to understand its environment and other computers.
That's really listen. Yeah, you have another hidden skill here. These examples and definitions are really good.
Thank you.
That's fantastic.
Use the ball, please.
If you had to give a 10-second pitch on why someone should study either electrical engineering or computer engineering, you can take your pick. What would you say?
I could probably do computer engineering just because you might be able to do electrical engineering. 10-second pitch. Okay. Start 15. Let's see. Computer engineering is great for when you want to understand how computers work and you want to build your own computer that can do whatever you want it to do.
Boom. 10 seconds. You're the only person that actually did 10 seconds because usually I'd be 10 seconds or around that.
Right. Yeah, no. I had to make sure.
Yes. If you could pick any fictional character to replace in their universe with your electrical and computer and CS knowledge, who would you replace?
That's a very good question. Oh, now I gotta.
It doesn't have to be fictional. It can be any character.
Yeah.
I mean, it doesn't have to be animated. It can be any character.
You know, it's crazy that my first, gut instinct was that dude. I think he's from, NCIS, like that hacker guy.
Okay.
Like, he just, can get into any, system, blah, blah, blah. He knows how to do that. Like, I don't know if I could, improve upon what he does because he's kind of a genius. Yeah. But, I would love to be in his position. Yeah. That's really cool. Mans can really just go... Oh, man. Oh, okay. Nice. Awesome. Yeah. Wow. Either that or, an electrical form of, kind of like a MacGyver type dude. Okay. You know what I'm saying? Yeah. Someone who could just build... MacGyver, if you don't know, is someone who could, he would have nothing but a paperclip in, a locked room and figure out how to get out of the locked room, right? So being, that kind of a person, but, only having, a 9-volt battery and a wire, you know what I mean, type deal. That's what I was.
That's cool. That's cool. Last question. If you had to give any piece of advice to either Johnathan of 12th grade year in high school or to any other 12th grader that wants to study electrical or computer engineering, what would you say? Don't give up from failure. I went into college getting a B once in my high school career. And you start making C's. And you start making C's, and that's hard. But if I were to give advice, you're at college to learn, and you don't know everything. Yes. Right? And some things are going to be hard, and you're going to have to learn them. So allow yourself to learn. You know what I mean? In high school, it's easy to get once you get the formula down. That's it. Rinse and repeat every single class. But here, it's no, some of the classes, there's no textbook for real. It's just projects, right? And the projects may not work. You know, that's very true. That's that's real life. So just let yourself fail and know that you'll be fine. You know, a lot of times even grad schools and stuff like that, they understand that engineering disciplines are hard, especially ours. They understand that it's difficult, and so if you need you're thinking, I gotta have a 4.0, a 3.8, 3.9 to get into grad school. No. Right. No. Some grad schools would be cool with you having a 3.0. Yeah. Or a 2.9 and you just have great experience. Great experience, great recommendations. Right. Yeah. You know, I have a 2.9, but your last internship, you knocked it out of the park so well that your boss wrote you a 3-page letter. That does way more than a 4.0 student, real talk, who has no practical experience. Right? Or even slight practical experience. Yeah. Just let yourself fail. Yes. You always bounce back. You will. Thank you so much, Johnathan. I really appreciate your time. Of course. Thank you. Awesome.